Hello, and we are now live. I think so, right? Yeah, we should be live now. There we go. So, like I said yesterday, we are going to be configuring first hop redundancy. So we are going to be configuring HSRP, Vrp, and GLBP. So HSRP, provides the default gateway redundancy using one active and one standby router, standardized about licensed by Cisco. Means that any like Juniper and all of those companies are able to use it, but it is licensed by Cisco system. Then we have Vrp, which is an open standard, and it can be used by any company. And then we have the GLBP, which is also a Cisco. It was developed by Cisco, so you can only use it with Cisco devices. So let's go ahead and start with HSRP. On the previous video, we configure VLAN, we configure trunk, we configure Ether channels, router and the stick. We did all of that. Also Dhcp and other good stuff. So if you missed those, go ahead and watch those. They have been posted on my YouTube channel. So let's go ahead and start. You can see that I have a lot of text in here. Those are the texts that I created. So I can keep going with this lab. And I'm going to add a couple more after this video. So NAT and PAT, we also have to do NAT and PAT. But let's go ahead and start with this configuration. So HSRP, NAT and PAT, AAA. Let's go ahead and move AAA over here. NAT and PAT is going to be over here. So let's go ahead and start. Let's go ahead and plug in with router 13, which is basically going to be, let's put it right here, my ISP. So basically I'm connecting to my Comcast router. Come on, so 0/3, 0/3. So we need to add a couple of IP addresses. This one's going to 20. That one. That 3. This is actually VLAN 4. So let's say for that 2. We can remove that. We can duplicate this one. It's going to be that 1. On this side, it's going to be 3.1. And 3.2 down here. All right, so let's go ahead and start with this. We are going to go into router 6. Hopefully I save all my configuration. Config T. So what we need to do is we need to configure, the first one that we're going to configure is going to be HSRP. So for HSRP, we need to have gigabit 0/0 interface or sub interface. I believe we need to configure in the sub interface. Maybe let's see, interface gigabit 0/0.3 IP. Or if we do standby version, yeah, we can do it from the sub interface. So that's what we're going to be doing. It's going to be from the sub interface because that's where we have configured, because we're doing router on a stick. So we cannot do it just from the regular interface. If we do show IP interface brief, you're going to see that I have configured this in the previous video on this sub interface. So that's where we need to configure the first hop redundancy, right? So let's go ahead and do that. We are going to do the first one that we're going to be doing is going to be HSRP. So you want to do a standby version, and you want to tell them what we are going to be using. So for the version, we are just going to keep version 1. The standby, then we need to go ahead and create the standby. If you do a question mark, you want to create the group number. That's what we are going to create right now. So the group number is going to be 1. This one needs to be, I believe it needs to be the same on the other side. So for router 5, we also need to configure for the same number. The same group number needs to be the same across the 2 routers. So group number 1, and then we are going to give it that IP, and that IP that I'm going to give it, that IP that we are going to be basically sharing between the 2 routers, going to be 192.168.3.100, right? Oops, forgot to put IP over here. There we go. So that 3.100, that's going to be the IP address that we're going to be sharing between the 2 routers. You can also set up the timers. If you want to set up the priority, you also are able to do authentication with an ND5 key string. But let's go ahead and set the standby 1 priority. The higher the priority, the better the chance we are going to have of becoming the active. So let's just put it 101. The default priority is 100. So since I marked this one as 101, and if I don't change this for router 5, router 6 is going to become the active, which means that it's going to be the one getting all the it's going to be doing other routing for this network. So standby 101, priority 101, standby preemption or preempt. So we want to do 1. So what this means is that if router 6 goes down and then router 5 takes over, whenever router 6 goes back up, and if it has a higher priority, then this one is going to become the active one more again. Okay, so now let's go ahead and do a standby. Another spell, standby 1. We are going to do authentication and the 5 key string. We are going to call this Cisco 123. All right, so we are done with this configuration with router 6. Now we need to go into router 5 and configure, and we also need to change the, let's go ahead and do this now, the Dhcp configuration. The first one, let's go ahead and do IP Dhcp excluded address, and we want to exclude 192.168.3.100. so my Dhcp server doesn't assign this to a device. So that's one of the things that you want to do. Another thing is that you want to go into IP Dhcp Pool VLAN. I think, let me see if I do show IP Dhcp Pool. So we have VLAN 3, so that's the name of my pool. So what we want to do is that we want to go into IP Dhcp Pool, and we need to change the default gateway. So we need to go into Pool VLAN 3, because the default gateway that I assigned is 192.168.3.1, but now we want to change it to 192.168.3.100, because that's the IP address of the of HSRP. So therefore we need to change it over here, and we need to say default. Come on, router slow. There we go. So we need to do default router 192.168.3.100. There we go. So now we are not using 192.168.3.1 anymore. We are using 192.168.3.100 because that's the IP address that is going to be shared between R6 and R5. Okay, so that is done. Let's go ahead and go to R5. And R5, we need to go ahead and enable config T. We need to go into interface gigabit 0/1 that 1.3. We are going to do a standby, and the standby we can just do version 1. Make sure that we're using version 1. Then standby 1 IP, the same IP address 192.168.3.100. Standby 1 priority. We're going to give it just 99. And we're not going to do preemption, but we need to do a standby authentication ND5 key string, and we put it as Cisco 123. So we configure the version, we configure the IP that we're going to be using. The priority I gave it lower. We didn't configure preemption, and we did configure that bad authentication. Look at that. What was the what did I configure on this side? So remote active, that is saying bad authentication. Did I do one? Oh, because I didn't put the group number, so we need to go ahead and go back. Let's say no, and then we can go ahead and add the group number. Don't forget to add the group numbers, or you're going to have this issue that I'm having right now. Group number 1. Stop it. No, there we go. So the issue was that I didn't put the 1, so I didn't specify the group, and that's why we were getting that bad authentication, because we basically didn't have a the password for it. But now it is working. If we do also need to go into, well, we don't need to do DHCP from here because we did the DHCP on router 6 and not in router 5. So now we have HSRP working for VLAN 3. Let's see if my devices got the change that we made. Well, that is loading. Let's go ahead and go over here and show IP. Is it HSRP? Nah. Show. I forgot what was the show commands that we are able to do is show standby brief, and you can see that router 6 has been configured on gigabit 0/0.3. Group number is 1, priority is 101. We are active. Where is the active? Local, so we are the one that is local. The standby is 192.168.3.10. Good. The virtual IP is 192.168.3.100. So that is great. So let's see if those devices got the new default router, which is 192.168.3.100. So IEF config. How do we? Let's see if we're able to ping 192.168.3.100. Okay, so we're able to ping that 3.100. Let's see if we're able to ping 192.168.4.1. We're able to do that. So it looks like it is working. If we do IF config, doesn't really show me the. So if you show the default router in Linux, I forgot how to do that. So So guys, how do you find is a route -n? Okay. Alright, so we see right here that we're still using 3.1. We don't want to use 3.1. We want to use 3.100. So what we could do is, how can we release and renew? Let's see if we, what if we unplug it and 0/3 and then plug it back in. 0/3. I just want to see if because we need to get that new gateway that we configure. Still the same, so I'll probably have to reboot it. So let me go ahead and just turn it off. And then we're going to turn it back on. So while that is going on, we need to do some other stuff. Like over here, we need to configure 20.1.3.2. So let's go ahead and go to config T, interface gigabit 0/2, IP address 20.1.3.2, no shutdown, exit. Then we want to do an IP route static, and then it's IP route. Okay, so we are going to add a send it to 20.1.3.1. There we go. So just a default route. So if you do show IP route, we have a gateway of last resort to 20.1.3.1, which is my ISP over here. So that's what I'm doing. Let's do WR. Let's go ahead and turn my Linux back on. Oh, look at that. I should be paying attention to YouTube. A lot of people helping me out. Does it shut down? No shutdown, tear down, delete? Probably too. That's a good. Should be paying attention to YouTube. Let's see. Show run all because of right. Okay. So let's go ahead and take a look at my Linux machine and see if we got that new default gateway. Let's route that in, and there it is. So we now are using 192.168.3.100. So that is good. So now what I want to do is I want to do a continuous ping, and I want to continue pinging. Let's see how this is going to work. So I need to first configure. Let's see which one I want to ping. I want to configure. We still got a lot to do. So router 5, router 6. Let's go ahead and configure router 5 with interface gigabit 0/3, IP address 192.168.3. I lied. 20.1.4.2. No shutdown. IP route to 20.1.4.1. So that is good. Let's see if, so from this device, from this VLAN 3, if I go ahead and ping 20.1.3.1, am I going to be able to get it back to down here? Because when I ping VLAN 4, the way that I'm going there, I'm going this way, and then I'm going via this way, right? So this is still using it. Okay, so let's go ahead and do ping 192.168.4.3. It should be one of these Linux down here. So while that is going on, let's go ahead and go into router 6 interface gigabit 0/0.3. Let's go ahead and shut this bad boy down. You see, so I'm still getting so you can see that HSRP went down and router 5 took over from standby to active. So that is good. So now let's see what's going to happen if I do a no shutdown to this one. Since I do the preemption, it should come back up and become the active router again. And there we go. Stay from listen to active, and this one should go from active to speak. So, and now to standby. So preemption worked for HSRP. So the switch you should need loop back on, yeah, there we go, loop back on ISP. Carl is on the right track. So if I do that loopback address router 3, let's go ahead and configure router 13. And now we're not going to track interfaces because I still got to do configure HSRP, then I have to do Vrp, and then I have to do GLBP. I'll be here all night if I start configuring the track, doing the track and all of that. Let's say no. Okay, so enable config T. Let's go to host name ISP interface gigabit 0/2. It's going to be an IP address of 20.1.3.1. Let's give it a no shutdown. So this one is the interface for the ISP. This one right here, 0/2. To verify, do ping one. Keep doing 192.20.1.3.2. There we go. Now let's do gigabit 0/3. This one should be 20.1.3.4.20.1.4.1. No shutdown. Now I should be able to do ping 20.1.4.2, which is router 5. There we go. So that is great. Now let's go ahead and configure interface loopback 8.8.8.8 loopback 8 IP address 8.8.8.8 255.255.255.255. So now I won't be able to ping 8.8.8.8 because guess what? Our 13 doesn't know where 192.168.3.1 is. Routes. IP route. If you want to go to 192.168.3.0, I want you to send it. I want you to send it to 20.1.3.1. Whoop. So IP route. Oh, that 3.2. You can also send it to this one down here. And there we go. So now we are pinging 8.8.8.8, which is a loopback on router 13. Thank you, Core, for that. And now we can go ahead and take a look what happens when the active goes down, active HSRP. Let's do a shutdown. Let's see how long it takes. So it went down. You can see that we cannot ping anymore. And it takes, so this one is now active. So I'm still unable to ping. Do show IP route. Let's see what car. So we have, if you want to get to this network, send it to 20.1.4.2. Yes, it is 3 seconds and then 10 seconds before by default. So this guy right here, so this guy took over 8.8.8.8. Oh, I forgot to do a route. Let me see, IP routes. So, oh, this is from the, oh, never mind. I was doing it wrong. Nope, it's not that. So, let me go ahead and take a look. So, if you, yeah, we'll go again. So, I will have to, yeah, static. So let's go ahead and go into, yeah, I won't be able to do what I wanted to do. R6, R5, I already configured R5. So it is the active, so that's fine for now. Because if I remove it, if we do a no IP route 192.168. But what if I is 20.1.1.4.2? So what I will need to do is yeah, let's go ahead and do that. That 3. That 3. That 2. And then here we go again. But I just wanted to show. Well, but now we can see. Yeah, we're not doing dynamic routing protocol. I was just doing static routes. I mean, I can go ahead and configure Ospf and that will work perfectly. But now it is working. You can see that it is not working. But then if I do another shutdown over here, it is going to stop sending the packets because R6 is going to become the active router. On standby, still sending. So let me go ahead and do this way. So that is fine. So that was HSRP. I wanted to do something, but I will have to configure either Ospf, GLBP, or whatever. But that's fine. Yeah, an IP SLA. Yep. For route tracking, and then I'll send the router. Yep. That's right. But that's fine. We are done with HSRP. Took me like 40 minutes, but that's fine. So HSRP is done for now. Let's go ahead and do. Let's go ahead and do. You are good. Let's go ahead and remove HSRP from R6. So if we do no standby 1, we have disable HSRP, no standby, interface gigabit 0/ for R5 is 0/1. Dot 3, no standby 1. So we can remove HSRP. So that was HSRP right there. So the next one that we can configure, they're basically almost like the same. It's basically the same for HSRP and Vrp. It's basically the same configuration. All you have to do is, instead of standby, we are going to just say Vrp for Vrp. So if you do Vrp and you want to do, let's do group 1, the IP address, let's keep it the same so we don't have to change it. That 3, that's 100. And then we can do Vrp priority, Vrp1 priority. You can do a question, you can see the levels. We can just put it 101. We can do Vrp1 preemption. Then we are going to do Vrp1 authentication, and the 5, you can see it's the same configuration, key string Cisco 123. Let's go ahead and do the same over here, Vrp1 the IP address that we are going to be sharing, Vrp the priority, we are going to just leave it the same, or we can do Vrp, let's do 1, let's say priority 98, Vrp 1, we need to do the authentication, and the 5, we are going to do a key string Cisco 123, making sure that it is the same, Cisco 123, Cisco 123. So now you can see that we have a master, and the master is R6. So if we do and show Vrp and brief, we can see that gigabit interface, or the sub interface, that 3, the group that we are using, the priority that we have, the time that it has. You can see the master, we are using preemption. You can see the master address, which is 192.168.3.1. So it is this R6 is the master. You can see the group address. And for router 5, we do show Vrp brief. You can see the interface. You can see the priority that it has. You can see that what is the state of it. So it is in the backup state. You can see the address of the master, which is R6 IP address, and you can see the IP address of the group address, right? So now if we go to config over here, and we do interface gigabit 0/0.3, and if we do a shutdown, what's going to happen is that R5 is going to become the master now, and this one is going to go down. So now if we do show Vrp brief, you can see that we're not a master anymore. You can see the group address that we're using, and if we do it from here, you can see that the master address changed to 192.168.3.10 because R5 has become the master, and you can see the priority. But if we do a no shutdown over here, we should become the master again, because we have a higher priority, and because we enable preemption. If we didn't have preemption, then R5 was just going to continue being the master, right? So if we do show brief, and it's really fast, do show Vrp brief. If we do it from over here, do show Vrp brief, you can see now it is backup. It was backup. R6 went down, we became the master. R6 came back up since we enabled preemption. We went down as a backup. You can see that the master is now that 3.1. So that's how you configure Vrp. It's natively implemented in Vrp. Same timers. I remember running to this. You can configure 1 second in the running config. Yep. There we go. So now what we could do is that let's go ahead and do show IP route. Let's go ahead and remove that static route. IP, let's configure Ospf IP route. Remove it. Let's remove it from over here to do show IP route. Let's configure Ospf. Okay. No IP route. So IP router course ID 1. So we are now going to inform that we are going to use a network. What are the networks that we have? We have 192.168.3.0, 255. Let's just add everything to area 0. We also have that 4, and we are also have 20.1.4.0. Do the same over here. Router Ospf 1 network 192.168.3.0. Oops. 0.0.0.255. Network 20.1.3.0. Okay, so what I'm doing is I'm configuring Ospf for router 5. I'm saying that router 5 is able to get to VLAN 3, which is 192.168.3.0 network, and it's also able to get to 192.168.4.0 network. And then I'm going to configure for the ISP. The ISP, we can go ahead and say remove these static routes, because if we keep it here, we won't be able. Ospf has a higher AD, and since it has a higher AD, then the static routes are going to be preferred, right? No matching route to remove. Oh, because I need to do right. Show IP route. Do show IP routes. There we go. So now let's go ahead and go to router. Ospf. Where's ID 1? Yep, the AD is 1 for static. Right? Yeah. So network, we are going to say that we have 20. That one, that's 3.0 255 area 0. There we go. We have a neighbor so far, and we have another neighbor. Cool. Network, we also need to add my we need to add the 8.8 network. So for 8.8, so we are going to go like this, area 0, and let's go ahead and go to R5. Well, let's go ahead and now go to my Linux device. Let's try to ping the 8. So we are now able to ping it, and this is going via R6. So when I want to do an R6, I want to take R6 down and see if R5 is going to take over. Interface gigabit 0/0.3 shut down. Let's shut it down. We are now, Ospf is down. Let's see what's going to happen. How long is it going to take for Ospf? So if we do Ospf show IP, there we go. So now it came back up. It took a couple seconds. I don't know how long it takes. There we go. Should be up. Can you? Yep. So it is now working. So as you can see now, R5, it's taking over R6 job. So now if we do a no shutdown, then R6 is going to take back over again as a master, and Ospf is up and running too. So that's how this first hop redundancy works. When one goes down, the other one takes over, and if you have configured preemption, and then the other one is going to take over again as soon as it's working again. So that is great. I was able to do what I wanted to show in the HSRP. All right, good beans. Thank you, Carl, for letting me know that I need to configure a dynamic routing protocol. Okay, so now we are done with HSRP. We are done with Vrp. Now let's go ahead and configure the GLBP, which is again basically the same. And before we can configure that, let's go ahead and do a no Vrp 1, so we can remove Vrp. Let's go ahead and do it from router 5 as well. interface gigabit 0/1.3, no Vrp, Vrp1. So let's go ahead and configure. GLBP, and GLBP we're going to configure for both. So what I'm going to say is that router 5 is going to be the master for VLAN 4, and router 6 is going to be the master for VLAN 3, right? So what we need to do is, let me see if I remove, I remember me removing show IP Dhcp Pool VLAN 4. Okay, so VLAN 4 still has, what is the default gateway? I think they still have the old. Let's go ahead and do show run include. Is that going to show me anything? Include Dhcp? Nope, nada. If I do a show run all, it's going to give me a lot of stuff. So let's see. Is IP Dhcp in here? Okay, we excluded 10. We didn't exclude that 4.100, and we also need to add that default router to be 192.168.4.100 for VLAN 4. So let's go ahead and do that. Config T IP Dhcp pool VLAN 4. We are going to say that the default router is going to be 192.168.4.100. Exit. We are going to do IP Dhcp excluder address 192.168.4.100. So that's good. Now let's go ahead and go to R6. Let's go ahead and start with R6. And like I said, R6 is going to be the master for VLAN 3, which is 192.168.3.0 network. Master is disabled. Cool. Okay. So let's go ahead and start with GLBP. So we are going to say under the interface, the sub interface, remember that sub interface because we're doing router on a stick. So GLBP, we are going to stick with group number 1, IP 192.168.3.100. We are going to say GLBP 1 preempt GLBP. What are we going to do? We are going to do GLBP 1 priority. Oops. What did I do? A lot of stuff. GLBP priority. Let's give it a priority of 102. You can also configure the timers, the hello and dead timers, but I believe that needs to match across. But I'm just going to leave it as a default because I don't need to mess with that right now. We can do the authentication. So we do GLBP 1 authentication. Again, MD5 key string, password Cisco 123, right? You can also add because the difference between the Vrp and HSRP is that GLBP, they are both going to be actively sending packets, right? So R6 and R5. So we are going to basically do some load balancing, and you can configure the load balancing that you want to be doing. So if you want to do GLBP 1 load balancing, and if you can see right now, you can see the host dependent. So it is going to load balance equally. Source MAC address determines the forward choice. You can either do a round robin load balance equally using each forward in turn, or you can do the weighted, so load balancing in proportion to the forward weighting. So you can do any of this, and that is something I believe that Vrp and HSRP do not do. HSRP has one active and the other one waiting for the other one to go down. Vrp does the same thing. So that's the key difference between that. So we are going to be configuring round robin for that. So now let's go ahead and go into R5, and let's go ahead into interface. Let me look at my topology. We are going to be configuring gigabit 0/1.3, and we are going to do a GLBP. Remember, the group number needs to be the same. Group number 1, IP 192.168.3.100. GLBP again 1. The priority, we're not going to mess with that. Preemption, we don't need to mess with that. Let's go ahead and do authentication, and the 5 key string Cisco 123. There we go, Cisco 123. So now we are going to do the GLBP, and we are going to do for GLBP, we are going to do the load balance GLBP 1 load balancing, and we are going to be doing the same, which is the round robin. There we go. So let's see any comments. Load balancing is the key difference. Thank you for stopping by, Andre. In GLBP, do they use one virtual MAC address to give the clients? Or is there multiple virtual MAC address with one device? I believe it's just they share. I believe they share just one virtual MAC address. If I'm wrong, if you are Googling right now, just let me know. I would like to know too for the exam. All right. So here we are. If we do a show GLBP GLBP brief, I believe. There we go. You can see that's the same interface. Oh, we can see a lot of information. The active router 3.1, which is a local. So we are sharing this. Let's do it from over here. If you do it, do show IP ARP. There are different virtual MAC addresses for same virtual IP that are given out, I believe. Okay, that's what it is. So do show GLBP brief. So let's see. So it looks like because again, also another key that I think I remember is that the they are sharing for layer 3. They are sharing the same IP, and they are sharing the same MAC address, as you can see right here. So this is the active router. I will need to read up on GLBP more. Active listen. Okay. So nice. Got to nail down a lot of the trivia type stuff, certification exam questions. The virtual MAC address is where X is the GBLP group number. And there we go. AVF, active virtual folder number. Thank you for that. Checking the documents. Thank you, Almighty. All right. So we are now done with the configuration for VLAN 3. Now let's go ahead and do VLAN 4, because remember, R6 is able to do VLAN 4 as well as R5, right? That's why we are doing this load balancing and all that. So for R6, I need to configure gigabit 0/1.4. And we are going to do GLBP 1. Let's go ahead and choose another number. 2 IP that we are going to be sharing 192.168.4.100. That's the one that we're going to be sharing. GLBP. The next one that we need to do, we are not going to do preemption, because remember R5 is going to be the one that I basically want to be in charge of everything. So let's go ahead and do authentication, just because. So GLBP 2 and authentication MD5 key string Cisco 123 again. That is my password for everything. And then we are going to also do the load balancing. GLBP 2 load balancing. We are doing round robin as well. Now let's go ahead and go to R5 and go into interface. I believe it is. Let's go ahead and put this down since we're done, so you can see my topology. Gigabit 0/0.4. GLBP 2 IP 192.168.4.100. GLBP 2. Let's go ahead and do the authentication so it can stop giving me those errors. Key string. Make sure you spell it right. Cisco 123. GLBP 2 priority. Let's go ahead and say 103. GLBP 2 preemption. There we go. Preempt. There we go. So now if we do show GLBP brief, now we can see that we are running it for gigabit 0/4 and gigabit 0/3. Right, there we go. The group number 2, group number 1. Let's go ahead and go to R6. GLBP brief. We see 3, and we can also see 4. Right, so we have configured that, which is kind of cool. Let's see if these devices on VLAN 4 have IP address 192.168.4.100. It's a router .n or route .n. I forgot about it. There we go. So they still do not have it. Let's go ahead and just stop it, and then we can start it up again. So we are going to keep GLBP 192.168. That's 3.100, and 192.168. That's 4.100. Let's go ahead and start the Linux devices again. Let's see how my server is keeping up. Look at that, 37%. I only spend like I think I only spent like $200 on this server, and look, I'm running a lot of stuff, and it's only a 16%. Even G, you gotta love it. Now let's go ahead and do mate terminal route n. There we go, 192.168. That's 4.100. So that is great. So now we have configured. We configure HSRP, which took me like 40 minutes. Then I configure Vrp. and then we ended up by configuring GLBP, and we are going to keep GLBP for this topology. So what do we have next? Next we have NAT. We are going to do NAT, network address translation. It's probably going to be port address translation. That's what we're going to be doing. We configure Ospf. That is good. So in the next video, we are going to be doing NAT and PAT. Then we are going to be doing we are going to add this other side over here with a couple switches. We're basically going to create like VLAN 5, and we are going to do an IPsec tunnel to so we can have an IPsec for that. Okay, Andrew, I see you. Thank you for watching this live. So VRF is also going to be configured. So the next video is going to be NAT, PAT, and we're also going to be configuring IPsec and probably also BGP. So we are going to configure in BGP as well. And over here we are going to be configuring NAT and PAT. I also want to configure port fast, BPDU guard as well. So port fast and BPDU guard, we are going to be adding it over here. And static, we are going to configure static NAT for these servers right here. And then over here VRF, and then we're probably going to finish by configuring AAA and SSH for other devices, so we are able to just remote in from a single device. So we are going to be using one of these devices to basically remote in and configure all of them just from one device, right? And we are probably going to be doing, I think I'm going to be doing some redistribution from Ospf into BGP, right, to go out into a network. So this is it for this live. Yeah, AAA is good. Yeah, should be good to go over. AAA, I like AAA. It's kind of cool. So thank you guys for tuning in. And if you guys have any suggestion, just go ahead and go to Twitter. And first of all, before you suggest something, just go ahead and follow me on Twitter at CCNA Daily Tips. If you have a Twitter account, if you don't have a Twitter account, go ahead and create a Twitter account and then follow me on Twitter. And then just, you know, you can just add me and I'll make your suggestion to keep going for this live topology, for these live videos. So thank you guys for watching, and I will see you in the next one. Have a good